All right, cool. So this is part 2, where where we left off here. So that's where we left off. So the scientific attitude, don't need to write any of this down, right? But the whole point of science, right? We're curious, we're skeptics, humble, we're critical thinkers, right? Trying to solve issues, trying to find the facts, whether we always like the answer or not. Theory. Hopefully you guys have gotten this, right? A theory is like the best understanding of whatever topic is at that point in time, right? So like it's the agreed upon scientific thing, like gravity theory, for what it is. Now, a theory can be proven correct as far as we know, or right, we have a hypothesis about something and it turns out to not be true. But that's theories, like right? Theory of gravity. Like we all accept that gravity is a thing. It's a theory, so like technically our understanding of it can change, but like that's the best way that we understand it. Scientific method, question, hypothesis, testing, conclusions, results. The biggest part about the scientific method, you ask a question, you do some research, blah, 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 blah. Test your hypothesis. Don't change it if it starts to not be true. Go through the whole thing and be like, hey, I was wrong. This is what happened. That's good. That's learning. All right. You will need to write these stuff down. So, operational definitions. And we'll do something with this in class as well, but a carefully worded statement of the exact, super important, exact procedures used in a research study. So unlike the dictionary, operational definitions describe concepts with precise procedures or measures. So if the hypothesis is saying like sleep-deprived people do worse on tests, that as a science, that means nothing. Because what does sleep-deprived actually mean? And what does it mean to do worse on a test? So operational definitions are of extreme importance because that is what allows research and experiments and studies to be replicated. So instead of saying like sleep-deprived people do worse on tests, you have that, but then you have sleep-deprived, right, as 2 or more hours less than a person's natural sleep. So if I only on average sleep 6 hours a night, but you sleep 8 hours a night, like sleep deprived doesn't mean, well, I got 6, so I'm sleep deprived. Like it's based on the person. So operational definitions, it has to be super, super clear, so that way whatever the study is can be replicated down to the exact meaning of words, the exact level of everything. So being like exceptionally precise is of the utmost importance. So a case study, a descriptive technique in which one individual or group, normally small groups, are studied in depth in the hope of revealing universal principles. Now, that's going to be an issue because realistically, because case studies are so focused on individuals, sometimes small groups, you can't actually then say this is representative of all people. What makes case studies awesome is we get to learn an abundance of information about one person, and it allows us to have a really, really good in-depth look at whatever we're trying to study. The downside of case studies is we can't then say this is true of all people because it's so individualized. We can learn a lot from it, but we can't say then this is true from all people. We're going to talk about Jeannie Wiley in class, so don't worry. Naturalistic observation, easiest way to do it is it's people watching. So like naturalistic observation, the biggest key, it's not about explaining behavior. It's just describing it and watching it. I think sometimes people like Jane Goodall, like, would not, when she went and like worked in Africa, she wasn't naturally observing the chimps. I think it was chimps, apes, chips. I don't know. Chimpanzees. I think it was chimpanzees. The issue, not the issue, but like some things that have come up out of like her findings is like the chimps knew she was there. So like technically they could have been, and that's the issue, we don't know how their behavior changed because of her presence. And even after a while where they like, accept her as one of their own in a way, like they still know that she's not a fellow chimp. So how does the presence of an outsider impact them? So she was not a naturalistic observer in that sense. We talked about this observer effect, Hawthorne effect, same thing. Boom, boom, boom. Blind observers are like the best way to do this. It'd be like me saying, hey, go stand there and watch what people do out in the parking lot and just describe it. They don't know what I'm actually looking for, so there's no bias that can creep in because they're just reporting what they're seeing. Versus I say, hey, watch how so-and-so moves around the parking lot or something like that. Surveys. Surveys are really, really great for collecting lots of data because you can get a lot of people to take a survey. But getting surveys done well is actually really hard. And there's a lot of issues that can come out of surveys. So wording effect, the way words are used and framed in a survey can have serious impacts on how people actually answer the question. So you can word it in a few different ways and you'll get different answers based on how you word it. Courtesy bias, that's people giving the answer they think the person wants to hear. Sampling bias, if I am taking a poll on leading up to the presidential race and I want to conduct a poll like, hey, who's going to win? If I only call people from like one specific town, the odds are like they might all have similar political beliefs and be like, oh my God, this candidate is super popular. Well, no, they're really only popular in like one area. So like where you pull people from is an issue. Obviously ties in with population. And then random sample. Again, who you are surveying and where they come from and all of that things impacts the data of the survey. So surveys are great, but they're hard to do well. Correlation. More than anything else, and I know you hear it a bunch, hopefully you hear it a bunch, and you'll hear it a bunch this year, correlation does not mean causation. So many things in the world correlate that have literally nothing to do with one another. So the biggest thing to be wary of is like, yes, sometimes correlation, there's something there, but you cannot draw true conclusions from correlational studies or things that correlate in general. The only thing you can really draw from things that correlate is that something else needs to be studied in an experiment. Only experiments prove causation. Correlation only shows that two things there's something going on where they both are correlated. But you don't know what it is. We're going to do some more work on correlations, but here's just so you can see it. So everything's on a scale from 1 to -1. So 1 is a perfect positive correlation. That just means as one thing goes up, so does the other. High positive, low positive, it's generally up. No correlation, there's nothing there. Negative correlation just means as like one thing increases, something is decreasing. Right, so oftentimes food intake and body weight, right? So the more food intake, the higher the body weight. More food, higher body, right? It's going up. Ice on roads, the more ice, the more car accidents, right? Both going up. Eye color and height, different eye colors, different height, right? There's no correlation. Number of cigarettes smoked and lifespan, typically would be like as more cigarettes are smoked, the shorter the lifespan, right? So that's how high just means, or positive, both things are going up. Negative means one's going up, right? Like one's going down. All right. That is part 2. Thanks.